coming out tonight. My name is Sadie Urban. I'm the events coordinator here at the Reserve. This talk is part of a year-long lecture series called the Rough Nuzum Lecture Series. It's funded in part by a grant from the Kickapoo Reforestation Fund, also known as the Nuzum Grant, and then also the Friends of the KBR also help with refreshments. Tonight we have, our talk is on ticks, which it's very, it's a very good topic now because they're just coming out, unfortunately. And we have Pellitteri. He's a retired entomologist from UW-Madison, and he's here to talk to us about give you an update on tick information. I do have a sign-in sheet that I would appreciate if everyone could sign in. I need to record attendance for grant reporting. So I'll hand it over to you.
Okay,
Thank you.
I'll apologize for two things. First of all, because there's ticks out there. And secondly, I have a bit of an ear infection, so if I start wobbling a little bit, it's because of the ear infection, not because I was surviving before. I will tell you, with running the diagnostic lab for almost 36 years for the department, I got to see all kinds of different insects and other arthropod issues. But nothing professionally has fascinated me as much as what has evolved in the last 30 years with ticks, in particular deer ticks, or what we really call the black-legged tick and Lyme disease. I have to, because of my profession, concentrate on the biology of the ticks. I can't deal with the medical side, although I will talk about the diseases that are involved. But Lyme disease in humans is a very complicated story, and if indeed you're interested in that, I think it would be worth getting a physician in if that's your interest. But we'll talk a little bit about what goes on with the ticks in Wisconsin. And as Sadie said, it is already tick season. And basically, you figure from the time the snow is off the ground and the temperature is at 50 degrees until we get a permanent snow in the fall is tick season. And I can tell you, I even had ticks come in the laboratory in January when we got a warm-up on a southern slope and things opened up. And so, and what's different for those of us who grew up in the state, it wasn't that way when I was a kid. And part of it is because of the different ticks. Now this comes from Door County, and this is a very fascinating picture somebody sent me. He didn't collect these and all put them together for the picture. This was crawling out underneath his cabin. And what we had figured was going on is he had a bunch of chipmunks that had been living underneath there and created the environment for the tick populations to explode from there and crawl out. So I'm going to concentrate my discussion on the ticks that affect humans. To be honest, there's more ticks out there, but some of them are very host specific. One on squirrels, one on rabbits and the like, and so, we could lecture about them, but then I'd have you for 3 hours, and you don't want to hear 3 hours worth of ticks. We talk about the ticks that we have to be concerned about. What we all call the wood tick is officially called the American dog tick. There is a related species called the winter tick, which I'll tell you has a very fascinating biology, not so much an issue for humans. What we have all called the deer tick is now been officially called the black-legged tick, because it turns out this tick, at one time we thought was a brand new tick to science. It's not. It's a tick that used to live and has lived down in Texas forever, and now has decided to move up in the Midwest. And it is given the common name both the bear tick and the deer tick, but technically it is one species that we call the black-legged tick. Then we'll talk about a new friend that is starting to show up, although so far in low numbers, called the Lone Star tick, and give you a little bit of background of how these things work. But this is kind of the murderer's row of the ticks. The one off to my far right is the American dog tick, the Lone Star tick, a female deer tick, and then a nymph of a deer tick. Now, what's kind of fascinating about ticks, it takes them 2 years to develop, from the time the egg hatches until the adult mates and lays eggs. And during that time, the tick only feeds 3 times. Now, this is going to have some very interesting implications as far as picking up diseases and the like. But one thing you have to admire is how something can exist for 3 years and only ingest 3 meals. It must be very efficient. as an animal to be able to sit out there and maintain itself. It also must be very patient, and ticks really are. Here we start with a fed tick. This is probably what you might have experienced on your dog if a tick had been there for 4 or 5 days. This is a female. Only the females swell this large. And they're going to use that protein source as a way of laying eggs. And females can lay anywhere from 1,500 to 2,000 eggs, and it will kill her. There's only one reproductive cycle going on with these adult ticks, which is really quite fascinating to me. And when they hatch into a little animal that we call the larval tick. And the way we identify it is, unlike adult ticks, which have 4 pairs of legs, larvae only have 3. And the interesting thing, for the most part, for all the diseases we're going to talk about, when a tick is a larvae, it is not carrying any disease, because it has not fed yet. It has not had the opportunity to acquire the disease from a potential host. These things are extremely small. That is the head of an insect pin. And I'll show you later a picture of one in my arm. And I honestly find that larvae don't get into humans very often because I think our skin is too thick, among other things. They're primarily rodent feeders. So the eggs hatch into this little larval stage, and generally speaking, larvae have a preference for small rodents. Mice in particular, chipmunks, those kind of things. If they're lucky enough to find a mouse, they'll feed for 3 or 4 days, they'll drop off, and then they literally have to molt their skin and transform into the next life stage, which we call the nymph. The nymph is still technically immature. It has 4 legs, so at least I can tell the difference. It again has to sit out there and wait for a host to come by. Most nymphs will feed on a wider variety of animals than larvae, and potentially people. And we'll talk about deer ticks in particular, black-legged ticks, that the nymph is probably the primary vector of disease in humans. But again, if they're lucky enough to find a host, feed for 3 or 4 days, drop off, they have to molt their skin, then they transform into adults. And many of the ticks have a preference for larger mammals when they're adults. Now, ticks then have to spend a lot of time out waiting for their next meal to come by. And one of the fascinating things is ticks don't have eyes. They can't see you. But they are very good at sensing carbon dioxide, heat, and movement. And if you ever watch a tick that is questing, they'll sit out on a tall piece of grass and kind of sit there kind of stationary. And if you blow on them or get close enough that they feel some heat, all of a sudden you'll see their little legs starting to move around. They're getting ready to grasp onto something. They will move up and down depending on the conditions. Very wet conditions, the ticks don't seem to be interested in questing. We find that when they're looking for a host depends on temperature, anything above 50 degrees, time of day. One of the fascinating studies my colleague Susan Paskowitz has come up with is she sent her students out at 2 o'clock in the morning to look for ticks. And guess what? There are more ticks looking for a host at that time than there is in the middle of the day. But if you think about when are you likely to find a mouse come crawling by? At night. So that makes a whole lot of sense biologically. If things get excessively dry, the ticks tend to be a little bit less active. But here's a tick questing. Very flat little animal. And there's a common misconception that ticks fall out of trees. Anybody ever heard that? Well, I think the problem is most of the ticks are from maybe knee level below, but if one were to come on to my pants, where's the first place it's likely to find skin? It's up on the head. It's going to crawl all the way up, end up here, and then all of a sudden, well, they must have come from up there. Generally not. I mean, it really, if you think about it, it doesn't make a lot of sense to go crawling up in a tree to find something to feed. You're much more likely to find a host close to the ground. Here's one of those nymphs. They also are really quite small. Now it's interesting that the ticks that we're talking about tonight are called hard ticks. There is another subgroup of ticks that are called soft ticks, that are primarily parasites, birds and bats, interesting enough, but not people. So we'll start with our friend, the American dog tick. This is a female. I'm going to show you how to tell the difference between males and females. It really isn't very hard. Here is one crawling on his arm. This one has not attached yet. It's not fed yet. The whole feeding mechanism really is a very fascinating thing to watch, and we'll talk a little bit about it. But again, talking a little bit about when they quest. It has to do any time that there is no snow on the ground and potentially there are animals active that they could feed on, and so they'll take advantage of it. The old-fashioned wood tick, I figured the season typically was from about the middle of April till about the 1st of July. At that time, they are starting to, the adults from the previous year are dying off, the nymphs are not looking for people, and so the season kind of shut down. What has changed with the black-legged tick is, as I said, is it is active at really any time. So here's a close-up of the tick, and this is what you would define as the head, but it's not a head like we think. It's a feeding mechanism. It has a central piece that it feeds with it. It reminds me of my thumb, and we call it the hypostome. And then it's got two little sensory devices called the palps, and that's it. So, you know, you think of the head, the brain, it doesn't work that way in a tick. What's also quite common in all of our hard ticks is this plate behind that feeding apparatus that we call a scutum. And the scutum will allow us to both sex the tick, but also, in some cases, identify the tick depending on what the markings are on the scutum. Now, this is the business end of a deer tick. And one of the things you notice, there's a lot of home remedies about how you remove ticks. Some say you turn them to the left, some say you turn them to the right, and the like. But if you look at the tick's mouth part, it is barbed like a fishhook. And what they will do is literally cut away into the skin, attach this, and then they glue it in on top of that. So you ever wonder why it's so difficult to get a tick that's been there for a while off? Because it's got this barbed hypostome that is glued into the host. So they do not attach. Or detach very easily. And this again is just a close-up. And to be honest, we can identify ticks. We have to go to this point of looking at the orientation of the hooks on the hypostome, especially for the relatives of the black-legged tick. It's really a big group of about 55 species, but as we mentioned, it's only really one that is an issue for people. So here's just a close-up of the feeding mechanism, seeing the attachment. Now, what's fascinating about this is when a tick gets on an animal, it takes it a number of hours to get that hypostome cut in, the thing attached, and then to glue in. Then, after 24, probably 36 hours, they start to feed. Why this is important is when you talk about the transmission of Lyme disease. If you remove a tick in the first day it gets on you, it hasn't started feeding yet, and because of that, it's not transmitting disease yet. It's, again, just setting up its housekeeping so it can start to feed. Now, the difference between the black-legged tick and the wood tick has to do with how long the hypostome is. It is much shorter in the wood tick, and so they're much easier to remove, and they don't glue it in near as much. So there's a biological difference why you see the problems more with deer ticks. Now here is a tick bite, and I can show you exactly where that came from. I was out bow hunting. And I know I picked the tick on Monday. I didn't find it till Friday. That's not good. You know, I'm just getting round enough now. I can't see on the belt line as well as I should. So even though I preach to inspect yourself every day when you're out in the woods, I didn't, and my wife reminds me of this all the time. And this is just purely a reaction to the tick bite itself. But part of it is because the tick was embedded so deeply, which is so common with these. And this is just, again, an immune reaction. And I've pulled the tick off, but you can see, again, I still have a bit of a hypostome left behind, which when people ask me what to worry about, it's kind of like having a sliver. I mean, it's not good, but it doesn't have anything to do with transmission of any other diseases. And hopefully it will eventually work out, or again, you can work it out. Now, on the other hand, you can overreact. I remember early on, I used to get samples from a physician up in Eau Claire to identify the ticks, which was very appropriate. But every time he took it out, it was like taking a major biopsy. There was so much tissue they took out of the person, like a punch. I couldn't believe it, because they're much easier to remove.
Sir?
Yes.
What, did you say that you just pulled it off from you?
Yes.
And so the part that's inside stays?
If it breaks off. Now, the best advice is slow and steady. I mean, that's the best chance you've got. And there are, I will show you, Now, later on I'll show you there's a little key device that we use on dogs in particular that aids in pulling, especially a heavily engorged tick. And you'll see how it works. It's just kind of a little slot and it kind of pulls. Okay, so start with our American dog tick. This is a female. You notice that white plate behind her head? That's that scutum that I talked about, that shield. And in particular, what's important here is the white markings that you see there. It's like somebody took a nail polish, white nail polish. Some have more than others, but it's very visible. Now, again, the official scientific name is American dog tick. We call them wood ticks. They are generally found in a much broader environment than we see with the deer tick. You can find them anywhere. We find them in downtown Madison, along the railroad right-of-way where people walk their dogs. I've seen one crawling on my screen at home on the west side of Madison in a typical suburban place. I mean, it doesn't surprise me. Any place you could potentially see animals, you will find these things. The adults are active from the spring until about the 1st of July, and then they seem to disappear. Either they have found a host and they have been successful in reproducing, or they have died because of not finding a host. Here again is a female, unfed, and you can see that plate. The difference in the males is that plate covers the whole back. And when a male feeds, it doesn't need this large amount of blood, so they don't swell like a great big bean when they're feeding. And this is just a close-up of the hypostome, that feeding apparatus with the two little antenna-like structures we call pelts, and those white markings. Remember those white markings. Female on the left, male on the right. Again, you can see how that plate has covered the whole back, and there's still some white markings there, maybe not quite as concentrated as you see on the female. And here is an engorged one. So ticks that have been feeding for a time, when they swell up, are harder to identify, because it's hard to see that little plate. But if you look with a little magnification, you can see it, and I can see there's markings on there. I mean, it's definitely, it's got some kind of whitish or silvery markings to it. And this host of characters here are all American dog ticks, the person up in Door County. Interesting enough, Door County it is extremely difficult to find a deer tick up there. As far as I'm aware of, we've only seen 3 deer ticks come in from Door County, which is a fascinating question to ask. Why? Because Door County is a diverse enough environment and whatnot. You'd think they'd be very happy up there, but they're not. Okay. What's interesting is the American dog tick is a common vector of Rocky Mountain spotted fever. But if you look at the historical records of the disease, people in Wisconsin, we've got the tick, we don't have the disease. And unlike what the disease would suggest, you think you get it in Colorado, the hot spots of it are in Oklahoma, and the like, and then also in the Carolinas and Virginia. So there are some interesting biological realities that we don't really totally understand of why these diseases are so concentrated. But this is historical reference in 5 years, and it doesn't change. The other thing is, when you hear about somebody that gets it, you always have to ask the question, have you been traveling? Because you might live in Wisconsin, but if you were visiting your cousin in Oklahoma, it's more likely that that's where you acquired the disease and then came here. Now, if you're a deer hunter, occasionally you will find when somebody gets a deer, the deer is absolutely covered with hundreds and hundreds of ticks. And a lot of people assume that these are deer ticks or American dog ticks. But there is a very fascinating tick called the winter tick that we find on deer. And we also find it on moose. This tick is implicated as one of the reasons why the moose populations are in such major decline up in parts of Minnesota and the like. At least this is one of the questions. And what's different about its biology is it's a one-host tick. Once it gets on an animal, after it feeds, it doesn't drop off, it stays there. Hangs out until it molts its skin, then feeds again. And so it will do all 3 feedings on the same animal. And so what you do is get this population buildup on the animal. And so it's not unusual to see, this is a moose. And there are, probably 150 ticks there. This is why we have graduate students who say, go count those things. And you can see where it can be quite disturbing. even animals are losing enough blood to worry about, indeed, that they might be getting anemic and the like. But the reason for it, as I said, is it's almost like the animal's a vacuum, and it absorbs these ticks and it just keeps building and building. And so you do see occasionally a deer with high number of tick loads, and it turns out to be these winter ticks. I will tell you they seem to be more prevalent in the northern part of the state than they do down here. But when we do deer surveys during the hunting season and look for ticks, this one shows up, even down here. And again, just another picture. Now, this is an interesting one. 10 years ago, if I was giving this lecture, we wouldn't even include this tick. This is a tick called the Lone Star tick. And if you've ever spent any time in the spring down in Missouri or the like, this is a very common tick down there. But it's not a tick that we consider to be established in Wisconsin. It's relatively easy to identify in the adult stage because it has a single dot right on the sputum. And here's just a close-up. Now I would tell you, historically when I ran the lab, I would occasionally, maybe once or twice a year, somebody would send me one of these ticks. They were always adults, and they were scattered throughout the state. I mean, I've got records from Barron County, I've got records from Outagamie County over by Appleton and the like, but there was never a pattern to show that we were getting immature stages which would suggest the tick's breeding here. So what we speculate is they're hitchhiking on a bird. Bird lands here, tick drops off, somebody finds it. Here again is that very distinctive marking. There is some difference in the shape of the sputum. I mean, there's some other things that I'm kind of glazing over that we use to verify the identification. But to me, that spot is just such a dead giveaway. Now, if you ever hear anybody talk about seed ticks down in Missouri, they're talking about the immature stage of the Lone Star tick. And somebody will talk about, you're having a picnic and you put out your blanket and the like, and you go to the car 2 hours later and you've got 150 ticks on you. And they're all little tiny ones. Those are all Lone Star ticks. And what had happened is the female had dropped a whole egg load in an area, and unfortunately you decided to picnic in that area. And all those little ticks migrated onto you at one time. And so it can be really quite scary, the concentrations that we see of those ticks. Now, what's interesting is historically the range was just about to the Wisconsin border. So as I said, we never, and that didn't seem to change up until about 5 years ago. And my colleague Susan Paskowitz, who is now the chairman of our department, is a medical entomologist, and she has been working with ticks and tick diseases. And we found breeding populations in the Arboretum in Madison. And since then, as we've sampled, we're seeing more and more of it. And this is one of the classic examples when I give a lecture on climate change, I use this tick. Because what it has done is it's extended its range northward, and we think it's because of the lack of cold weather in the winter. And again, those of us that are old enough to remember 35 below is a common phenomenon when I was growing up, and now we mumble about 5 below. I mean, there is enough. And so, when I do public radio, one of my favorite things to say is the governor moved us to Missouri 10 years ago and didn't tell us. But this is one of those examples of something that was typically a Missouri animal that now is in the southern, we figure, third of the state. And we anticipate it will become more prevalent. So, one of the most fascinating things, it is not a competent vector of Lyme disease. There's a couple other things that it is spreading. We're not seeing those diseases here yet. But a fascinating sidelight to this tick is it was discovered about 4 years ago that certain individuals that live in areas where this tick is common develop an allergy to red meats because of the tick bites that they receive over their lifetime. Now, not everybody. It's a certain subset of people. And from what I know of it is, once you develop the allergy, it may never go away. And how they found it is very fascinating. It's worth looking up on the internet. It was more by accident. It had to do with some cancer drugs and the like. But it's added a whole new dilemma to tick bites for people in the United States. Okay. So the big stinker is the black-legged tick. Or is that what we typically call the deer or bear tick around here. And it is somewhat smaller in the adult stage than the quote wood tick, but I figure it's about 2/3 the size when I look at it. And the thing that I look for is two things. if you look very closely, all the legs, the hypostome, and that little scutal plate, that little shield, are all black. Okay, that's where the name black-legged tick comes from. The only white you see there is a reflection from the light when I took the picture. The other thing is, look at how orange that body is. Now this is an unfed tick, and the feeding status will affect the color of the tick to some degree. But it's almost a bright orange, whereas the quote wood tick to me is kind of a rusty brown color. So here's just a close-up of the female, and a comparison of the wood tick and the black-legged tick. Now, when they feed, it gets more difficult because they swell, they tend to turn gray, and I have unfed and fed females there. I can still see that dark scutum though, with no marking on it. So that's what we look. Now, you know, back when this was first unfolding, they used to give those little tick cards out there that were quite useful. What I've tended to find now is most people who spend any time in the woods don't really have that much difficulty distinguishing them, at least in the western side of the state where the ticks have been more prevalent. Here's just a female. The other thing we use to identify it is, you see that little horseshoe-like marking down? There's a little dot, looks like a button. That's the anal opening of the tick, and it's got that little horseshoe type thing, which is characteristic of all the ticks in this group. So even if they're fed, we can see that under the microscope. And here again is a well-fed female. It's probably been on a person or a dog for about 4 to 5 days, and is now dropped off, and will start to process that blood into eggs. And that process will take a couple weeks. Okay, so the big thing about this, as we've talked about, mentioned a number of times, they're out already. So if anybody was finding ticks, the chance of it being a wood tick or deer tick is a little hard to call at this time of the year. But in the fall of the year, 98% of the ticks you can pick up are black-legged ticks, with my experience. In fact, after the 1st of July, the probability goes up. And this has a little bit to do with their life cycles. The first deer tick caught in Wisconsin was picked up in the 1970s up in Spooner. And there was a graduate student in our department that was doing a study of the parasites of mice. And he found the tick, and he published a paper on it. And at that time, he called it the black-legged tick of Texas, because that's what it was. And this was way out of the normal range. The normal range of that tick is down in Texas, Oklahoma, and we find one in Wisconsin, so it was well worth publishing. This is about 10 years before we even knew what Lyme disease was. So we had a record of the tick, but we really didn't know what we had. From that time, the tick has spread dramatically from that northwest part of the state, and a very similar story has happened in the east. And we find in this picture, which is what, 9 years difference, you can see the expanded range to take in a good portion of upper Minnesota, getting rather concentrated in parts of Illinois and the like, into Michigan, and the East Coast is almost become solid versus the first tick, yes?
So in the 1996 graphic in Wisconsin, it looks very isolated. There's no corridor leading to Wisconsin. So what's the thought of how it originated in the state?
Great question. When we don't understand things, there's always the spaceship theory. It turns out that I was lucky enough, one of the people that does Lyme disease research from the CDC was in the department, so we got about 2 hours to just sit and jump up and down and talk about ticks and stuff. So I posed that question to him. And in particular, historically, in the history of this state in particular, during the Ice Age, we didn't have any ticks, we didn't have any earthworms, we didn't have any deer, we had nothing. So they had to get reestablished. And what is interesting is, again, you could say for how many thousands of years birds have migrated up here carrying ticks with them, but what you needed is a male and female of this tick to be dropped close enough to each other to be able to find each other. But the other very important factor is deer density. That low deer densities will not support this tick. In fact, there have been islands off of Connecticut where they have removed the deer, and basically it takes about a year or two for it to see, again, because of the slow reproductive cycle, the tick numbers drop dramatically. And you could argue you could keep the deer away, they would have none. The unfortunate side of that is the deer densities we're talking about are not realistic. 1 or 2 per square mile. I mean, it isn't going to happen. So, but there's that interesting. So, we believe that they reestablished. Now, originally when this tick started to show up in Connecticut, and we started to understand Lyme disease, that's when they described the tick as a brand new species. And the reason they did that is because morphologically, the ticks they found in Connecticut and the ticks they found in Texas, you couldn't identify. But what always was unsettling is the closer you got to where the ticks overlapped, morphologically, you physically couldn't look at them. And with DNA technology, what we find out is it wasn't a valid species. It was just another population. So we know that this tick was originally from Texas. It's reestablished up here. The other thing is you can prove genetically it's an isolated population. There's not as much genetic diversity in the ticks in Wisconsin as there is in the endemic area down in Texas. So kind of a fascinating story, but the key is deer. Interesting enough. So the name deer tick probably is more appropriate than the black-legged tick. So, what's interesting about this tick is that the different life stages are somewhat seasonal. The adult black-legged tick is basically a spring phenomena and a fall phenomena. And the immature stages are the middle of the summer. And the ticks that we see now in the spring are honestly the ones that survived from last fall. And they will go till probably about the 1st of May, and then they just seem to peter out. So it's really kind of interesting to watch that dynamic. In fact, it was interesting in my laboratory. The magic date was the 15th of October. I would not see an adult black-legged tick until the 15th of October. Then it's like you turned a light on, and all of a sudden they started coming in. And it was patterned year after year after year. Now, they'll stay from October until whenever, first week of December if the weather's right. And as I said, then they survive. The other thing that people often ask is, what effect does the winter have on ticks? I have never seen any effect. No snow, lots of snow, very cold, not cold, it doesn't matter. They're going to survive. So, this particular tick has a preference in the larval stage to feed on very small animals, in particular mice and rodents. The nymph is a broader range, and the adults have this interesting behavioral trait of preferring large animals and seem to depend on deer to sustain themselves. They can feed on other animals, but if there's no deer in the environment, they're in big trouble. Here's a larval tick. The thing about this to remember is that it is not carrying any disease. It's just hatched from an egg and it's clean. Here's one in my arm. Don't ask me how I found this. It was by accident. And I'm not totally sure where I acquired it. But all of a sudden there was a little bit of a mole where I didn't think I saw one on my forearm. I put it under the scope. The mole had legs. I said, oh, this is interesting. Cut it out. It turned out to be a larval tick. In fact, that's the little critter there. You can see very easily it's feeding. But if this tick was feeding on a mouse that had any one of a number of diseases, it picks those diseases up and now it's infected for the rest of its life. And so what it turns out is all these diseases we're going to go through are basically rodent diseases. So the larvae is fed, it molts its skin, it transforms into the next life stage, which is the nymph. Still a pretty small animal. There's one sitting on my fingernail. I won't say they're invisible, but there's not a whole lot to them. They're most active in the middle of the summer. And we find with humans in particular that most humans acquire Lyme disease in the middle of the summer, so we point to this as being the source more than the adults. And I think two things are going on. One, it just makes sense if you're picking it up and this is the only life stage. But these things are small enough to overlook, so they're less likely to be pulled off. Even though adults have twice the amount of disease than the nymphs do, they're more likely removed before they get an opportunity to transmit, at least in humans. And there, again, is just a close-up. Now, when people were sending me ticks, we were always interested in what the species was, but the other thing is, was it feeding or not? I can tell that that nymph is feeding because I can see literally those little dark streaks in there are its intestines, and they're filled with blood. So, as we said, interesting enough, even though the tick season's there is a relationship that the immature stage of tick seems to be the one that is more likely to transmit diseases to people. Now, the interesting thing about the male deer tick, or black-legged tick, is in the adult stage, it does not vector any disease because it's not feeding. Its mouth parts are modified for sperm transfer. So it's a reproductive feeding, which is absolutely fascinating that it goes through it. You can tell the sputum, the big plate, which is characteristic of the males. So people would send me males they'd find on them, but they were never embedded because that's not what they're about. They're on the host looking for a female to mate. So here is a picture of a nymph and an adult male to give you just a size reference. Again, very dark animals. The mating of ticks is just bizarre. Right? There's no reason to go into any deeper than that. So, we talked a little bit about this. There's a lot of home remedies for removing ticks. The studies have basically shown us that nothing, as far as nail polish or burning the little stinkers or things, have any help. In fact, you worry about doing tissue damage that can open it up to infections and other problems. So the slow steady is as good as it goes. There are specialized tweezers. Again, for dogs, they have these little keys that are made. And basically what allows you to is grasp as close as you can down to that feeding side of it. You don't want to take the abdomen and squeeze it because all you're doing is getting body fluids injected into the host, which increases the chance of transmission of disease. Whereas if you get as close as you can to the base and slow and steady, and again, if it breaks off, you have a, to be honest, the outer part of the so it's like a little piece of plastic. So, you may get an infection because it's a wound, but not because of that, and it will eventually work its way out. So, as we were studying this tick moving into the area, one of the fascinating things we found is you have to work a lot harder to find black-legged ticks than you do regular wood ticks. And if I had to explain it to you, think about people who like to hunt grouse and what kind of areas they like to crawl around to find grouse. That's where you find these ticks. We don't find these ticks in people's backyards in Madison. We don't find these ticks in mowed areas. We don't find these ticks in anything other than wooded areas, not just grassland, but wooded areas that have a lot of raspberries and understory, just thick, mean stuff that you normally wouldn't want to walk through, but if you're a crazy grouse hunter, that's exactly what you're looking for. And so that's been very fascinating to watch. In fact, I often thought we could find a plant indicator to tell us the right habitat that would define the habitat. We've not been able to do that. We found some relationships with river corridors and moisture levels and other things, but nothing that really is the dead giveaway. But it's gotten to the point now, I almost can feel where I'm going to find the ticks or not. And even though I spend a lot of time in the woods, if I'm in an open woods that has, not much understory, I don't worry about finding black-legged ticks at all. So we don't find them in a mature pine forest. But if you think about it, it's a desert. It's an ecological desert as far as insects and things, because there are all a bunch of dead pine needles and they sit on the ground. That's not a good place for a tick to be. We don't find them in Christmas tree plantations. And you think about it, you got deer and everything else coming through, and part of it, honestly, in a lot of, especially our lighter soils in this state, we've got some mound-building ants that are great predators. I don't think the tick stands a chance. I think that if they were dropped off in that environment, first of all, it's probably a little bit too dry, but secondly, the ants are going to eat them. So we don't find them there. But if you do find the right spot, I've had people say that, I went from my tree stand to my truck, I crawled down the hill, and I had 60 ticks on me. And I believe them. I mean, if you get in the right spot, the densities are really quite dramatic. Okay, transmission of disease. A number of diseases. I changed this slide before this talk because it turns out that there are now at least 3 organisms related to Lyme disease that we associate with ticks, but also some other ones. But the big thing is that the competent vector, the tick that transmits these diseases, is always the black-legged tick. For some reason, it is much more competent with these diseases. Now, if you expand this list, you find that the Lone Star tick spreads something that we call star disease, which is a different bacterium. But the most part, the big player is that black-legged tick. So that's why we spend the most time concentrating about it. And again, if you analyze what's going on here, is as those ticks are feeding on rodents, they become infected, and then they are capable of bridging those diseases. So what we're talking about here are rodent diseases they're bridging into other animals, whether it's dogs, horses, or people. And as I said, what's interesting is I can assure you almost every 2 to 3 years a new organism pops up, which complicates the diagnosis of these problems, it complicates the treatment, but explains a little bit what's going on. The classic Lyme disease is a Borrelia called Borrelia burgdorferi. There is a Lyme disease in Europe. It is related to burgdorferi, but the symptoms are different. People don't get the arthritic symptoms that we get here as kind of third stage Lyme disease. They tend to get this ulceration that shows up on the skin years after the exposure. What's confusing it now is Borrelia myonii has just been named. I mean, been named within the last few months. And some of these organisms are apparently quite common, but they don't make people sick, or at least we can't correlate it very easily. So as I said, it's really kind of a complicated story, unfortunately. So if you define the ones that we understand, there are basically 6 diseases that we find. The tick must pick it up. Larvae start clean. The nymphs have fed once, they get 1 opportunity to get it. The adults have fed twice, they get 2 opportunities. So guess what? The amount of disease is twice as high in the adults as it is the nymphs. And we point to the white-footed mouse as being the most competent vector or competent reservoir, but it turns out that chipmunks and other rodents do play a part of the story. And so when you're understanding the relationship of Lyme disease in ticks, you also have to understand the rodent populations and how they differ. And there have been really interesting ecological studies. Study out east showed us that the amount of Lyme disease in the area is higher when the coyote populations are high and lower when the fox populations are high. Now, fox and coyotes don't get along. And what it has to do is that the fox apparently are much more effective at reducing the rodent population. So if you reduce the rodent populations, you're going to affect ultimately the Lyme disease. There's also been a study to relate the amount of Lyme disease to how many acorns drop. But if you sit and look at the study, what they find is if you've got a heavy nut load, the mouse populations go up. Within a year or 2, you're going to see the disease populations go up. And when there's no acorns, the mice go down, less mice, less disease. So very fascinating stories. And we don't understand all the webs on here, but to me. So white-footed mice, chipmunks, and shrews. Birds don't seem to be very important. They don't seem to hold the organism very well. And deer are a dead end. If deer acquire the spirochete, they don't seem to be capable of giving it back to the ticks. But the other part of the story is adult ticks, once they are going to feed again. So they're not going to have the opportunity. So some of it has to do with the biology, but it also has to do with how the organism apparently works. And as far as I am aware of, we don't know of any negative effects in deer to Lyme disease. Now, one of the arguments has always been is if a deer develops serious problems, it's going to be eaten by something else, we're not going to be able to see it, but there have not been that relationship that I'm aware of. So, the common vector is black-legged ticks. You will see occasionally reports on the internet that the wood tick can spread Lyme disease. It has never been shown in the laboratory, and it's been looked at and looked at and looked at. When this first started, people were even saying that deer flies were spreading Lyme disease. Now, part of the problem is if you catch a deer fly, it's got blood on it, and you can find the spirochete in the blood, you can say, yes, it's got it. But what you have to prove is, can it spread it? Can it transmit? And that's what they're not capable of. So, the history is quite fascinating. The tick first showed up that we're aware of back in the 1930s in the small islands around Connecticut. Now again, it probably traces back to something that happened down south and got reestablished, and out east they spread from there. And they can go back and look into the stomachs of those ticks that were caught back in the 40s and look for the presence of Lyme, and they find it. Very low numbers, so you can kind of get the history of it. But what happened is in areas of around Lyme, Connecticut, a large number of children were developing arthritis, much higher than they should. They investigated and turned out to find that this was a complication of this tick disease that they first discovered. And so that's where the name comes from. It was interesting that the first case in Wisconsin was in a physician that we know of. He developed a very strange rash. He happened to be a grouse hunter, interesting enough, up in the Spooner area. He developed this odd rash they couldn't quite figure out. They gave him an antibiotic, went away, didn't have any more complications. But it was at least published, and you can trace it back, and that was probably the first verified case of Lyme disease, and that was back in the early 80s in the state. So, we look at the big risk map. We're in the dead center now. Again, what I found fascinating is from that original thing is to watch the tick movement, and it definitely was much heavier on the western edge of the state and much slighter, and we didn't fill in the other counties until the last 10 years. We didn't find a tick in Racine until about 10 years ago. And so it was slow when I think about it. Now the tick can't crawl very far, but ticks hitchhike on birds all the time. So the tick should be spread everywhere very quickly, but that's not the way this story took off. Now, as I said, from that original spot in the northwest, we've seen it go, and it's always been on the west side of the Wisconsin River that seemed to be the hot spot, although it has things that filled in. I've watched it in Dane County. We were talking beforehand. It's been interesting to watch in Madison. They got to about Middleton and they stopped. So they just gave up. Now, it turns out that the habitat west of Madison is more hilly. You know, it's part of the driftless area, whereas we get the glaciated area. But now, one of the big hot spots is in Waukesha County in the Kettle Moraine. So they have now established quite well. Now, what's really quite fascinating is, you know, a lot of the diagnosis for Lyme disease is done by blood diseases or blood tests and like. And in Wisconsin, the cases range between 20 and 44 per 100,000 people. In New Hampshire, it's quite a bit higher. But as people have looked at the numbers, the first thing that catches your attention is the steady increase that comes on. The other thing that catches your attention is recently we've now found out that probably only 10% of the cases are getting reported. So it's really much higher than any of those numbers. Nobody can give you accurate terms, but we know that was severely underdiagnosed. Now the other thing that was really fascinating to me is as we watched, aside from the tick moving, the percentage of ticks that carry Lyme disease has been looked at. And it started relatively slow, 3, 4, 5%. For the longest time in my career, the average in the adults were about 15%. Now the average statewide for about the last 5 to 7 years has been 40%. Now these are very important numbers because the CDC guidelines for treating people for Lyme disease states that if a tick was on your person for more than 24 hours and you know it was a black-legged tick and better than 20% of the ticks in your state are positive for Lyme disease, you should be treated 1 day with doxycycline as a preventative treatment. So you've not shown any symptoms, but this is a preventative treatment. We're at 40%. So if the one piece that you remember of anything that I tell you tonight, if you know you had a black-legged tick, you know you were out hiking 2 days ago and looks like it's been there attached, you call your doctor and you tell them the CDC guidelines state 1 day's antibiotic, 100%, clear up, no problem. The complications from that disease is when it's not treated initially and then it goes systemic and it's a much more difficult story. So, as I said, 40%, and the interesting thing is the study site we have in the Kettle Moraine in southern Wisconsin, Waukesha area, we have 80%. 4 out of 5 adult ticks are carrying the disease, which to me is just phenomenal. Now, when you look at some of the distribution maps, you've got to remember where all the people live. And what these don't tell you is where they acquire it. So you look at this and you say, holy cow, Bean County is a hot spot. But it turns out a lot of those people picked up the disease when they were vacationing and elsewhere, and so this is a little bit deceptive. But it's really quite easy to see that relatively concentrated area. And what's interesting is most of the other diseases that are transmitted have somewhat similar stories. So classic Lyme is supposed to have this bullseye-like rash. that shows up 60% of the time. Sometimes it's easy to call it a bullseye. It can go systemic. Sometimes it only presents like heat rash. Like I said, from the medical side, physicians really have a difficult time dealing with it. People will report severe flu-like and very fatigue and body aches, usually within 10 to 12 days of being exposed to this. And then it can go away without treatment. But unfortunately, there are other things that come on later. And in particular, some of this is really your body kind of fighting back. And so we have everything from some nerve issues that go on, facial paralysis, and a classic kind of hard to define arthritis that can come and go in some people, and other maladies that is associated with it. And some people won't even report encephalitis associated with this. So really, and the farther you go down this list, the harder it is for the physicians to treat, unfortunately, and to tell you what's going on. But going back to the story of how the ticks feed, as I had mentioned, when the tick gets on you, it is really not technically feeding that first 24 to 36 hours, and that's why they don't transmit. And that's why the recommendations are, if you pull the ticks off the same day they get on your person, you're not going to have a problem. Now, because the nymphs have only fed once, they have half the amount of infectivity, so the average would be 20%. 1 in 5 nymphs is carrying. 2 in 5 adults is carrying Lyme disease in the state on average. And as I said, the CDC talks about this. So my doctor's used to me calling him up and pleading, and he's very reasonable about this. Honestly, if your physician is not, and from my experiences, most physicians are very willing. And again, you think about it, even though you'd rather not take antibiotics if you don't need to, taking 1 day, just be done with it, is a much better alternative than letting the disease go until you get symptoms, and then you're taking for 3 or 4 weeks and the like, or maybe even more. Okay, what's complicated the story is there are other diseases. Anaplasmosis is another organism that is transmitted by the tick. It has similar types of initial reactions, fever, headaches, those kind of things, but you usually don't see a rash. They have a somewhat different blood test that they have to run to confirm it, but it does respond well to antibiotics. And interesting enough, you look at where anaplasmosis is showing up, and it's the same places where Lyme is, which is the same places where the black-legged tick is. And so in 2011, unfortunately I can't get more recent figures than this, we had 572 confirmed cases of this in Wisconsin. So that's not a number to ignore. Whereas, 10 years ago it really was just an occasional one. Again, we tend to see the symptoms within a week to 3 weeks of the initial exposure. And for whatever reasons, it seems to present more often in older people. Now, I don't know if it's because we hike more than younger people. It probably has to do a bit with immune systems. So some people are getting exposed and not getting sick is really things going on. Now we have another disease on top of that called Ehrlichiosis. And this indeed seems to be more in the northern part of the state as far as the disease, but it continues to spread and become more of an issue. Again, it is deemed to be a rodent disease that the tick is bridging into other animals. And if we look at the time that people acquire this disease, it relates to the activity of the nymphal stage of the black-legged tick very nicely. So we have seen this increase. So this is complicated, and it's interesting. I have a colleague, Tom German, lives in Iowa County, works at the university. Tom is now retired. Tom is an outdoors person. Became very, very ill for a couple months. And, they did the Lyme test. They couldn't, they were negative and the like. And so they just didn't think of anything. It turned out what Tom had was Anaplasmosis. And when they finally figured out and they treated him, he came. But boy, he was having a stinker of a time there. And unfortunately, you hear those stories are more common than you would like. To even complicate it worse, not as common, but there's a disease called Babesiosis, which is like malaria. Honestly, it's related to malaria as an organism that's also transmitted by the deer tick, or black-legged tick. We've only seen a handful of cases of this. In particular, it's one of those those diseases that people that are in good health don't seem to show much symptoms, but if you're immune compromised or have other things going on, it can become fatal. And so, again, flu-like symptoms, 45 cases confirmed in the state in 2011. I said, it's just really, it's fascinating but scary when you see these kind of things going on. And another auricula has been discovered. As I said, I expect every 2 years to have somebody find something new, and you trace back, and the story always seems to be the same thing. It's something else in the rodents that have. I'm sorry?
Are these mutations that you're seeing, or these are just totally new diseases?
Once they finally put a name on it, it appears to be a new disease rather than a variant of a given disease. So they find enough difference in the DNA to be able to make the argument. But, so, let's talk about protecting yourself. Wear clothes. Wear more clothes than you think you need. Basically, what you're doing is covering up your skin, your exposed skin. And the less skin that's available, the better. Some people say white clothes. The tick doesn't care the color of the clothes, but it's easier to see a tick on light-colored clothing than it is dark-colored clothing. Stay out of the woods. Well, most of us, that's not going so well. You can tuck your pant legs just because that, again, forces the tick to climb up. The kind of clothes you wear, this is not good stuff to hike in. Any clothes that have any kind of nap to it, they hang on so much easier. When we want to collect ticks, our sophisticated collection technique is to take an old wool blanket and drag it behind us, and they literally latch onto it. You wonder why dogs are such good at picking up ticks? Because they're like a magnet. Where you wear a brushed cotton or something else, and you're less likely to give the tick something to hang on to when it comes by. So even, people that like to go out and trout fish, if you got waders on, I think a tick's going to have a heck of a time grasping on to the neoprene or rubber in particular. The confusion that I find is everything that is sold for tick treatments is called a repellent. But the products don't perform this. The true repellent is DEET. And what DEET does is it does not kill the tick. The tick doesn't like where it is, so it moves somewhere else. So if I spray myself and forget to spray that little spot behind the ear, a tick could find that to be a nice place to start to feed. Now DEET used according to directions apparently is about 98% effective in the study. So it's really very effective. But what I think is a better choice is the Permethrin sprays that are sold as a repellent, but they are not a repellent. They kill the tick. Now they do repel it somewhat, but they kill the tick. If the tick walks on a treated surface, it will die. So it really isn't a kerosene. It is a tick-killing agent. And so this stuff is sold more in sporting goods stores and the like. And you don't have to spray it daily like you do DEET, but you cannot spray it on your skin according to label directions. Interesting enough, if kids get lice, you know what we give them is a shampoo with Permethrin on it. So, but you don't want to expose yourself to more of this stuff than you have to. But even after it dries, if the tick walks on your clothes, so, the Carhartts that I use when I'm out in the woods, cutting trees and doing stuff, I treat about every 2 weeks. You can even go farther than that. There's clothing this is U.S. Army research, that they can impregnate the Permethrin in there and you go through 10, 15, 20 washings and it will still work. So, if the tick walks on it, it's going to die before it has any opportunity to transmit. To me, that is better protection than just a sheer repellent. Now, people always are looking for ways to cut corners. And there is a lot of Permethrin. You use Permethrin, you can buy Permethrin sprays to put on your vegetables to kill cabbage worms and the like. But it's not legal to use the vegetable spray on your clothing. Or what some people will do is they can go to Farm and Fleet and whatnot, they can buy it by the gallon. You can buy it as a livestock spray, you can buy it in all kinds of things, and they soak their clothes in it. Then I get worried about the carriers in that stuff. It was made for killing termites. It's not going to be the same stuff as they're making, even though the active ingredient is, but the other things that are in there. So people are taking risks by using this stuff in a manner that's not consistent with what the label says. The label defines if something's properly used, and there's a reason. Even though it might be cheaper, that's because it's formulated differently, among other things. So, Now there are some things you can do to the environment around you. And basically, anything you can do to reduce the habitat that the ticks are happy in. So, mowed lawns are a terrible place for ticks. You know, it's like a desert as far as they're concerned. So, mowing trails both creates a dry environment, but it also, there's no vegetation for the ticks to sit and hang on. But when you start walking on the edges and walk down, that's where you get the exposure from the ticks. So, not bad. Not quite as good. What it seems to be is more, whatever retains moisture is good for the ticks, whatever keeps things dry is not. So by going in and raking off the leaf litter in an area, they have reduced the tick numbers by 92%. Now, what the problem is, you know, you've got a small yard where your grandchildren play and your pets go out, that's okay. But if you've got 15 acres, you're going to laugh at me because it's not practical to go out and treat those large of areas. So the areas close by, you can do some things to modify the environment and the like. Anything that makes it dry, opening up is better. It's interesting out in Connecticut where the ticks seem to be a little more prevalent in people's lawns there than they are here, but I think part of that is a little bit more of a maritime climate because it's got higher humidity. They literally will put bricks between where they stop mowing and where the wood starts to put a barrier for the ticks. Now, interesting enough, even soapy water will kill ticks. You know, if you don't want to use standard insecticides, there are less insecticidal soaps will work. But the only way it works is to use enough pressure that you're literally shaking the leaves up into the air because you're driving the stuff down to where the ticks are hiding is what it does. And one tick spray a year is more than sufficient. Now, the ticks take 2 years to reproduce, so it's not like they're going to explode a week after you treat. They don't work that way. We don't do much of this. I mean, there's a lot of things you can do, but, you know, again, if you own woods, how are you going to spray your woods? I mean, it really isn't very practical. So I'll just give you a couple other things that people are looking at, and then we'll open it up to questions. This one's very fascinating to me. And this honestly originally started back in the early 90s. One of the researchers at Harvard realized that permethrin would kill the ticks. And so what he did is he started treating cotton balls, throwing them out in the environment, and the mice would pick them up and take them into their nest and thereby kill the ticks. It works. It works quite well. The unfortunate thing is when they started to sell this stuff, they charge an arm and a leg for it. And so it's a technology that really never took off, but it really is a very valid technology. And if you think of it, you're using far less insecticide that way than if you're going out and spraying everything, you know, acres and acres of habitat. And so that was one of the strategies. Well, with that in mind, we're all going after the rodents. Another company is basically using frontline fipronil, where they use a bait box, they draw the rodents in, and they don't, when the rodent goes through, they treat it with frontline. It just kind of rubs on it, and then they run off, and we're doing the same thing. This is very effective. What's the cost of frontline on a dog?
$12 a month.
Okay. What would you say if I told you you had a quarter-acre lot, and if you were going to buy these bait boxes, it would cost you $350? Not because of a lot of chemical. Now, they're trying to get their developmental costs back. But this technology didn't take off because they priced themselves out of the market. But again, you think about ecologically, what's a saner way of doing this stuff is this kind of technology. Another one that's being looked at out east is treating the deer. Is when the deer come in to feed, we have them rub up against some rollers that are treated, and now we kill the ticks on the deer. This also is effective, but it's expensive. You know, lots of labor involved, feed, and we can't feed, you know, we got chronic wasting these, I mean, there's all kinds of other complicating issues that come into it. But just to show you some of the things that people have looked at. Okay, forget this one, there's just a couple other ones so, bottom line, I think it's very reasonable for people to continue to enjoy the outdoors. You just have to keep your guard. And to me, doing tick checks after you go for a hike is a good idea. I think if you're in areas that are known for lots of ticks, I think the precaution of treating your clothing before you go is a good idea. And as I said, especially if you spend a lot of time in, you can look into some of this clothing that is kind of permanently treated. Because if you can prevent the tick from getting on you, there's no way you're going to get sick. If you do indeed have a tick there for a period of time, get some help, bring it into the doctor. Many times they'll be able to identify it, or at least. Now, as far as I'm aware of, up at Gunderson, they were doing some tick testing, but I think you have to pay for that. There is no state lab that I know that will test for the presence. And to be honest, when this was first unfolding, the only people that we were recommending that had the tick tested were women who were expecting, because the conversation was, why give them antibiotics and expose the fetus? And so if you could tell, at least could help. But for the rest of us, now we're at such a high level of infectivity and the like. To me, if it's the right kind of tick that's been there long enough, I think it's reasonable to consider to be treating a precaution. So, with that, I'd be happy to entertain any questions. Yes?
How long does a tick live, the deer tick specifically, live if they don't feed when they're supposed to feed?
It depends a bit on temperature and humidity, but 2 or 3 months, easy. Easy. I could argue. So when the first tick shows up, the new adult tick in the 15th of October, that tick will still be alive in the next June. It'll probably die off by then.
But that's an adult.
That's an adult.
Okay. How about the nymph?
The nymphs are going to be most active. They basically have a 3 to 4 month window in the summer. And interesting enough, if you go out and look for nymphs when you start to get into that October, they're just not there. I mean, the numbers have just, and I think it's natural mortality. Now, if a tick lays 2,000 eggs, you're guessing that probably only 3 to 4 make it to adulthood. I mean, they have tremendous amount of their own natural predators and other things that prevent them. But that's their strategy in life, is to lay a whole bunch of eggs so just a small number can survive and we can sustain, and they do. And as I said, the interaction between wildlife, populations, and ticks, it's just, to me, fascinating. And there's so many understood. I mean, what does a skunk fit into this equation? We don't know. I don't think it's very important, but it might have a part of if you wanted to know the whole picture of what's going on with Lyme disease, I think you have to understand how these diseases are moving through all kinds of different wildlife. And can a tick feed on the skunk and pick it up? I don't know. It hasn't been looked at. But definitely the hot players are those rodents that we talked about. We know that that's the most important.
So if you go in your house with a tick on your clothes and you put your clothes on a hook, I mean, you'd have to wait months, or you have to wash it just to get rid of those ticks on your clothes that might be there.
The environment in a house is really quite a bit more hostile. And so, I've experienced, I've gone camping and threw all the camping gear down in the basement, and you come back 3 or 4 days later and there's a tick crawling on it. So it doesn't surprise me for them to go a week or two, but nothing past that point. I find that, as I said, it's just too dry, too hostile. They're not going. I'm not worried. They'll never breed in the house, and they're not going to survive very long in the house. The other thing that's interesting about ticks, because of the way they feed, they're not like mosquitoes. One can land on you, and then you disturb it and go land. Ticks, this is such a long process. So even if usually if a tick falls off your animal, I'm not worried about that tick getting on you. That's just not the way they work.
One thing I've heard for years, and what I always do is say, if you put it outside in the woods, you're afraid of ticks on your clothes, throw them right in the dryer for about 20 minutes on hot, and that'll kill them.
Definitely kill them. Kills bed bugs too. Dryers are our friend. Insects and ticks and the like have no ability to cool their body. So the critical temperature for most of those things is about 115 degrees. So it's not overly high, and they just die from desiccation. They just overheat. Yes?
So an adult female tick that's infected lays 2,000 eggs. Those eggs are not, that infection is not passed on to... Not passed on.
The only one, and I skipped over it really quick, is there now is another organism called Powassan virus. And this virus, we don't understand a whole lot about it, but it does spread to the eggs. We call it transovirial. And so there's something going on, but all these other organisms not been shown that it, thank goodness, because it would make life very complicated if it did. You know, so we have those same questions with mosquito diseases, and once in a while they do, but most of the time they don't, thank goodness.
Is UW doing a lot of research in this area, or have funds been cut to this kind of research? It seems like Wisconsin would be just a stellar place to be doing research.
I will say that Susan has had ongoing research with ticks, but it's more because of her general interest. You know, the big dollars of 20 years ago when this story was unfolded, basically, it started at Harvard. It seemed to stay at Harvard, but that's, we won't get into politics of that. And the other side of it that I thought was unfortunate, I'm an old-fashioned entomologist. I deal with whole organisms. A lot of the stuff was going on, doing very interesting things with DNA, but trying to understand what was hatching in the natural environment I thought was a little bit slow. But I will tell you, people like fish and whatnot, there's some very fascinating studies. In fact, there's a whole book on the ecology of Lyme disease. And it shows you what we know and don't know. So there's some pretty neat stuff going on. But Lyme disease in Wisconsin isn't the same as Lyme disease in Connecticut to me. I mean, when I hear about their tick distributions, now part of it, you know, they report more ticks in people's yards. But they're talking not the average person's yard. You know, you own an estate in Connecticut that's 20 acres in the middle of the woods. That's not a yard to me, that's a house in the woods. And that's a different environment than a house in town with a mowed lawn, no trees, no bushes. Every once in a while I would get a case of somebody that would find a black-legged tick on their dog in Madison with no travel history. Okay? So somehow that tick was picked up in the yard, and I just told you we don't see that. But what I never saw was somebody saying, well, I found one this week, I found one last week, you know, a number. It was just a single one. So that, I can at least suggest that maybe it was a tick again. It was on a bird, dropped off, it was there, a lonesome tick. I can see where you can acquire it. But as far as breeding, we did not see it. The other thing that I saw early in the game is somebody would go out. I remember somebody sent me 10 larval ticks they pulled off their 2-year-old that was playing in the yard. If you think about a tick dropping a whole bunch of eggs, okay, they all hatch, you can see you're there at the wrong time. The interesting thing is you go back to the yard 2 weeks later and try to find a tick and you can't buy one. So there are circumstances, I can understand when the tick's there for a short period of time, but as I said, a mowed lawn is a hostile environment as far as ticks are concerned. So that's one thing that you can consider. Like I said, the more areas you mow and keep the kids confined to that, keep the pets confined to that, which, you know, I know that's not realistic, but, you know, those are the kind of adjustments I think you would make to cover.
There's just such a tremendous financial impact on, I'm in with dogs and associated with a veterinary clinic, and we're spending, you know, hundreds and hundreds and hundreds of dollars trying to protect our dogs every single year, and it's a huge financial impact.
Yeah, it is, and again, you know, for those people, if you talk hunting breeds and whatnot that are getting in the environments they're exposed constantly, it is an issue, and you know, different animals respond differently. To be honest, you know, again, this isn't my area of expertise, but dogs don't get as much as I would even expect for as much exposure as they get. You know, which is a fascinating question. Is there natural immunity in some animals? I don't know.
Well, we are seeing some dogs are actually clearing themselves. So where you were saying, if you find a tick that's been embedded and you do 1 day of doxy, you treat for 1 day. Whereas with dogs, it is until you see symptoms. You don't treat until you see symptoms.
Has anybody ever looked at, again, prophylactic treatments of dogs?
It's a huge discussion, and I have said that because if we do a 4-day snap on a dog and we come up with Lyme and Anaplasmosis, I want to go ahead and just go ahead and treat the dog for 30 days with doxy. And the new veterinary guidelines are, we don't treat unless we see symptoms. Well, unless you don't know the dog really well, how do you know if the dog is symptomatic or not? So if you don't know that dog and you know you don't see a change in behavior, and sometimes we don't see anything until the dog is actually crashing. Dogs have a tendency to really hide symptoms very well. They don't whine and cry like people do.
But, you know, the other, I was absolutely amazed. I was on a program a little over ago with a physician, and we were talking, and they there was a shortage of doxycycline. And so they were, again, this was up in Rhineland, where they were hesitant, or Minocqua, they were hesitant to give people the preventative. And I'm thinking, one pill, be done, versus 30 days worth of pills. I mean, I understand, but I knew where she was coming from, but it didn't seem to make a whole lot of sense to me.
Doxy's come back down again. You know, it was a thing where a couple of companies came in and started buying up all of the things that went into making doxycycline and drove the price sky high. It's all come back down again, so it's readily available.
From $8 to $600.
Yeah,
down to $40.
it's really easy to get.
Well, the bottom line, I don't think we will not see this stuff go away. If anything, we see the amount of problems increasing. I mean, it just seems obvious.
We were worried that there was a market manipulation.
Oh, no, that part, yes. No, yeah.
Yeah.
I agree.
So more and more people coming down with Lyme and Anaplasmosis, and more dogs coming down with it, and horses, that there was some market manipulation with the doxycycline.
Afterwards, I want to chat with you about horses, because that's something. But, okay. Other questions? Yeah.
I just wanted to mention that we're finding with our dog last fall that Frontline is no longer working. He'd been on Frontline all summer and into the fall, and we were finding tons of deer ticks on him. So we have switched him to another drug that's supposed to be more effective. And I did some online research, and people all over the U.S. are reporting that Frontline is.
Yeah, and I don't know if it's so much resistance as I don't think Frontline is as effective as some of the other
Yeah, it had worked for him for years, but it's not working now.
But we're seeing heavier loads of ticks now that the dogs are running into. So fipronil, when used properly 5 years ago, was great.
Yeah.
It's not as effective now, and I think it's because we're seeing heavier loads out in the environment.
Now, I'll tell you, the one thing that I have seen climatic-wise affect the ticks is significant drought. In 1988, when we had that crazy drought, it knocked the population down, and it took years to recover.
Yeah.
But that's the only part of it. But again, that speaks to me of the microenvironment manipulations you can do. The ticks don't do well in dry environments. You don't find ticks on the beach.
Don't water your yard. Don't water your grass.
Right. You don't want lush things. Now, again, if you're interested in the spray thing, what they're doing is spraying before you get much vegetation growth, so within the next couple, 3 weeks, and just spraying the edges of the yard, you know, only in 5-10 feet to get kind of a barrier. And so, and the chemicals, just about any garden insecticide, honestly seems to have efficacy. Even the old insecticide I know is 7-carbaryl, which has been around for forever, is extremely effective. And there are Permethrin sprays that you can use. But as I said, if you're not comfortable with that, you can buy insecticidal soap. But what I fear is you cannot do it with a hand pump sprayer. There's not enough pressure. You need something that's going to, you know, run PSI or more. It's going to just shake the devil so that you drive this stuff in. So.
There's also a tremendous deer management issue in southwestern Wisconsin. Where I live, it's not well uncommon to see 3 and 4 dead deer on the side of on my road. I mean,
see, and
the deer
it's the stories,
are incredible.
You know, I grew up in Madison, but the story of, you know, you read the stories of people in Dodgeville. You know, when I grew up back in the 40s, if somebody saw a deer, we published it in the paper. You know, and so, but they say there was no ticks when I was a kid. Well, yeah, there was no ticks because there's no deer. I mean, there is that relationship. And the reality, as I said, you know, one of the areas I hunt was ground zero for CWD. So they did everything they could to reduce the deer populations there. It didn't happen, not even,
no.
They didn't even get within, you know, I think the deer population went down about 30 per square mile. That's the best they could do. And as I said, if you want to affect the tick numbers, you're talking 1 or 2 per square mile, it's not realistic. So people that talk about that aspect of it, unless it's a closed system that you've got total control over, it's not going to happen. But it's interesting, the studies where they were able to do that, they grossly, without any other animals taken out of the environment. So.
On that black-legged tick, when it bites you, it's hard to pull out. You say it glues in. How does it naturally release itself?
It gives some enzymes that basically melt the cement, and then it just backs out. But it takes time. That's why it's not like something that latches on and like this. It's a relatively slow process.
It
And
hurts too.
the percentage of, or the length of the hyperstome, there's more mouth to it than it is with the wood tick. The wood tick's just a stubby little thing, whereas with the black-legged tick, it's this long, with multiple barbs. It's really, as I said, scary looking underneath the microscope. Okay, well, I'll be around. If you want to chat, I do appreciate the attention.
Okay, I'd like to thank